Okay, talk about interpreting slopes, areas, accumulated areas. And the whole point here is the interpretation depends solely on the interpretation of any trapezoid. Now say interpretation of a single trapezoid. Examples, and we've seen these examples. If your trapezoids represent speed versus clock time, if a trapezoid represents speed versus clock time, then of course every trapezoid is going to represent speed versus clock time. The slopes of those trapezoids, the slope of any individual trapezoid represents an average rate of change of speed with respect to, I used t for clock time, didn't have room to write it all out. Okay, so that the slopes of your various trapezoids, if you have a bunch of trapezoids, each of these slopes will represent an average speed over the corresponding interval. The areas represent approximate distances covered. So the area of an individual trapezoid represents the distance covered for that trapezoid. So each trapezoid in a graph would represent a distance covered. And then talking about the accumulated areas, the accumulated area represents the total distance. Through, badly written, let me fix it. Okay, total distance through the end of the subinterval, whatever subinterval we have. If we have speed versus clock time, then total distance through the end of this interval will be the accumulated area. Total distance starting at the original interval up to this end of this subinterval. In the example of pay rates versus clock time, typical trapezoid will have slopes that represent the average rate of change of salary or pay rate with respect to time, clock time in this case. And the areas are going to represent approximate earnings. An area of an individual trapezoid is the approximate earning during the corresponding interval. And accumulated area is going to be the total earning through the end of whatever subinterval you're looking at. Recall that we've also looked at the meaning of a trapezoid for value of investment versus clock time, in which case slopes would represent the rates at which the investment changes and with respect to clock time, and areas would have no significant interpretation. Force versus position, whereas we saw slopes represent the rate at which the force changes as position changes, and areas represent, turns out, work on the area of a trapezoid corresponds to the work done on the corresponding interval. So that the total accumulated area under graph here would represent the total work or energy expended over the entire interval. So each trapezoid would be the work over that interval. The total accumulated area through the end of a trapezoid would be the work done from the beginning through the position corresponding to the end of that trapezoid. Again, we didn't consider accumulated areas here because areas have no significant interpretation when we're talking about the value of an investment versus clock time. Position versus clock time, similar in many ways to value of an investment versus clock time, in that the slope certainly has an interpretation, rate of change of the position. The area has no significant interpretation. so that the accumulated area is going to have no significant interpretation. And you might want to review these a little bit and think a little bit more about what they're telling you, what those graphs are telling you, and try to get an even better feel for what these slopes and areas mean and how they're interpreted. Now, looking at the trapezoidal approximation graph as a whole, we've already seen that the accumulated area represents, in those cases where the areas have interpretation, the total accumulation of whatever the quantity is represented by the area from the point A up to the end of a given trapezoid, up to the end of the interval represented by the given trapezoid. The slopes, well, you have a bunch of slopes, and we see that these are average slopes over intervals. Now, in this case, the intervals are short enough that the average slope is pretty close to the actual slope of the graph, at least on this trapezoid. On this trapezoid, we see that the graph has some curvature, so the slope of the graph starts out steeper than the average slope, reaches a maximum, and then comes down to a slope that's less than the average slope, so that the average slope doesn't represent the actual slope at this point very well, nor does it represent the actual slope at this point very well. And similar comments can be made about these two intervals as sketched. So, if we want to approximate the average or approximate actual slopes a little better, we could subdivide and make more trapezoids. And then at any point, the slope of the trapezoid would be a better approximation of the slope of the actual curve. We'll talk about that in the subsequent discussion. The point is then that if the intervals are short enough, then our graph slopes, our trapezoid slopes, are going to be good representations of the actual slopes of the graph and the quantities, rate of change of the speed with respect to time, rate of change of salary with respect to time, force versus position, rate of change of force with respect to position, etc. The slopes of the individual trapezoids will be good approximations if the intervals are short enough. Now, there's some qualifications about that, but that's the general idea, and we're going to discuss that in the next segment.